My name is Patrick. I'm the chair of the Cork region. I would like to welcome everyone here in the room and online to today's lecture on erosion control with Geosynthetic Cementitious Composite mats. Our lecture is delivered by Ryan McKeever. Ryan is a technical sales representative with Concrete Canvas Limited, covering Ireland and Scotland, and has represented the company for 7 years. He has over 15 years experience working in construction and civil engineering sectors in a variety of technical sales, business development roles throughout Canada, the UK and Ireland. Involved with Geosynthetic products since 2011, Ryan provides technical support and training to clients throughout the region. So I'd like to welcome Ryan today.
Thanks very much, Patrick. And thanks everyone for dialing in today. We really appreciate your time dialing into this presentation on geosynthetic cementitious composite mats. So thanks for the introduction, Patrick. I have my contact details on the screen here in front of you today. Feel free to get in touch if there's any questions afterwards. As Patrick said, you can use the Q&A function. So the presentation itself today should last in around 35 or 40 minutes with some time for questions at the end. I'm based in Navan in County Meath with Concrete Canvas, covering the Scottish and Irish regions for just over 7 years. But I thought I'd start the presentation off with an introduction into what is a GCCM. So a GCCM stands for a Geosynthetic Cementitious Composite Mat, or concrete on a roll. So it's quite a unique geosynthetic material where its physical properties change from flexible in its prehydrated state to rigid upon hydration. So the following slide is just a quick illustration of how the material performs both in its prehydrated state, as you can see on the screen here in front of you. So it does change from that flexible state to rigid after you hydrate it, and the performance of the cementitious layer is essential to GCCM durability in exposed erosion control applications. So there's 4 different elements to a concrete canvas GCCM material. But essentially it's defined as a flexible concrete-filled geosynthetic product that hardens on hydration to form a thin, durable, fiber-reinforced concrete layer. So the 4 elements include the polyester hydrophilic top surface, a reinforcing fiber matrix that runs through the material, a dry concrete mix within the material itself, and then finally a water-impermeable PVC back membrane. So we'll go through each one in further detail shortly. But just to let everyone know that it's designed for your non-structural erosion control applications, and it's certified by the British Board of Agreement for a durability lifespan in excess of 120 years for your erosion control and weed suppression applications. So it's a long-term durability within the material. So I mentioned the top surface is your fibrous top surface. In the field, this acts hydrophilically. So this is the section of concrete canvas that you should hydrate in the field. It wicks in the water very, very quickly, but it's also tight enough to contain the dust and the cementitious fill within the material. So there's a very low washout rate, less than 3% within the GCCM material. The second component is the 3-dimensional fiber matrix. So these synthetic fibers, as you'll see in the slide here, they run in a Z fashion through the material, and they're a very important element of a GCCM product. They perform 3 different functions. Firstly, they prevent dislocation of the cement fines. So basically, even if you hang this material on a vertical plane, perhaps for protecting the slope, it still maintains its uniform density. It also prevents any crack propagation after the material has set in the field. And thirdly, it contributes to the ultimate tensile strength of the material as well. So an important component. The third element is the actual dry cementitious powder mix itself, which has a very high early strength gain. It gains 60% strength within 24 hours, and it has a 28-day compressive strength of 60 MPa for the middle thickness or type 2 material. And then finally, on the bottom, we have a PVC rear face, which is your geosynthetic component, and everything in the GCCM, the concrete cementitious component, is designed to protect this from any damage in the field. So that is your back component that should be protected from your overlying concrete material. So I appreciate that GCCMs might be a new term for some people who've dialed in today, But just to let people know that it is recognized by the ASTM International Standards Organization. So there's now a number of GCCM specific standards that covers this class of construction material. This covers everything from material sampling, testing and installation. But the most important standard I just wanted to point out, particularly for designers who are working on civil projects for erosion control needs, is ASTM D8364. And that is the standard specification for GCCMs. And again, there's further details on that standard coming up. But overall, the benefits of specifying GCCMs to ASTM D8364 for designers, we have a really simple process, detailed, simple, safe, and secure, which essentially means that if you're designing a project to the relevant ASTM standard, you're ensuring you're specifying the right product, and it's ensuring that you're meeting the minimum performance requirements set out by that standard. In terms of the in-service performance in the field as well, you ensure it's safe, that it has the relevant data and relevant testing. And in terms of secure, the contractor knows that they're procuring the correct material in the market. So it's just a really good way for QC for designers on projects. In terms of projects, there's global coverage now, and the GCCM global footprint is continuing to grow. It's now in over 80 countries worldwide. So everywhere in blue on that map in front of you shows where GCCMs have been adopted and specified and installed. Just in terms of the core application areas for the product and for the materials, there's 4 key application areas. You have watercourses, slopes, weed suppression, and containment structures. In the presentation today, I'm going to focus mostly on watercourses, slopes, and weed suppression. But just keep in mind that all of these different applications can be used and designed with GCCMs. In terms of the actual core applications, the first one for us is channel lining. So this involves the rapid lining of channels, ditches, gullies, spillways, and canals. The GCCM material tends to be very quick to install, up to 10 times quicker than traditional hard armor solutions such as poured concrete. There's other applications such as slope protection. Just keep in mind that GCCM is there to design to prevent further weathering of a slope, to prevent any further erosion. It's not for slope stabilization. However, it can be used in conjunction with soil anchors and a wire mesh to give it that stabilizing effect. The third application is for bund lining, and this typically involves the encapsulation of an earth bund, trapezoidal earth bund, and provides protection against burrowing animals, perhaps for containment on certain applications in the petrochemical sector, and ultimately for providing weed suppression on different plants. Concrete mediation is also a popular application of GCCMs. Typically, clients will have existing assets that are coming to the end of their design life. They wish to prolong that design life, and they'll use a GCCM to do so. The material can be put into service within 24 hours because of the high early strength gain concrete used. And it also has a very thin footprint, which allows them to preserve the volume capacity within a flume or a watercourse. And finally, it can be used for weed suppression. And this tends to be underneath security perimeter fencing, underneath access points in the rail and road sectors, or for line of sight crossings in different areas in the rail sector as well. We'll have some case studies later in the presentation going through some of those applications, but just keep in mind, it is a quite versatile material, GCCM, and it can be used for alternative applications such as culvert repair, gabing reinforcement. So just keep in mind, there is other applications out there in the market too. In terms of delivery format, what we typically say is, depending on where the project's located and some of the restrictions on site, we'll give a recommendation on the correct type of format of roll. So on the left-hand side, we have our large bulk rolls. In GCCM, we can get up to 170 square meters of coverage on just one pallet. They're ideal where you have a project that's located in an easy to access area and where you have heavy plant available. It can be quite heavy. It's 1,500 kilograms per roll. So typically a supplier will provide a spreader beam that goes through the GCCM bulk roll, and you can deploy it using a heavy plant on site. It tends to be very efficient because you can cut it to length on site, which saves on wastage. However, on a lot of projects, particularly in Ireland, if it's a difficult to access location, the middle format of batch rolls can be ideal, where you can get up to 5 or 10 square meters of coverage per roll. They weigh up to 70 kilograms per roll, and a 2-person lift for each roll. You can simply install it with hand tools, and a water source. You don't need heavy plant to install the batch rolls. And then finally, we have our wide rolls on the right-hand side, which are available up to 3.3 meters wide. Keep in mind, the wide roll is ideal where you have perhaps a straight uniform channel of constant profile, or you have a larger project or a larger slope where you want to minimize the amount of joints required in the field. But again, for the wide rolls, similar to the bulk rolls, you do need good access at heavy plant for deployment. All formats are delivered in the same fashion, which is palletized and in shrink-wrapped plastic packaging, as you can see in the photograph here. The shelf life for a GCCM is 2 years from manufacture, simply because of the cementitious build within the material. And keep in mind, if a contractor is actually storing this outdoors before they install the material, we typically recommend putting additional tarpaulins over the material just to keep any water out. So you can see the bulk roll in action on the left-hand side with the spreader beam being deployed from an excavator on site. And in terms of physical properties of the material, there's 3 different types of strength classes for a GCCM. Type 1, Type 2, and Type 3. And you can see here the thicknesses change depending on the type. So we have a 5 millimeter, 7 millimeter, and 11 millimeter thickness. Keep in mind that the size of the rolls will get smaller as the material gets thicker. That's simply to keep it within the weight range for deployment. And then just in terms of the classification of GCCM materials by application, as I said, we have 3 different types of GCCMs. Type 1 is the 5 millimeter thickness. And you can see here, this is typically used where you have low shear stress and low velocity applications with limited traffic. So the likes of slope applications, as you can see in the photograph here, but also for the likes of weed suppression, bund lining, and the remediation of concrete hydraulic structures. For the Type 2 material, this is typically used when you're using it for hydraulic applications. As you can see from the photograph here, for the likes of water courses, we'd recommend the Type 2. It can handle higher shear stress and flow velocity applications, and this can include everything from channel lining, culvert lining, and bund protection, depending on the project. And then there's a Type 3, which is 11 millimeters thick. And again, this can be used for similar applications, but perhaps you have a looser subgrade or you have higher abrasion or wear requirements on a particular project. Again, Type 3 tends to be the bulk rolls are slightly less at 80 square meter per roll, but you have your 11 millimeters thickness per roll. I mentioned at the start that a GCCM is quite a unique product where the actual physical properties change from flexible to rigid on hydration, and the data sheet reflects this. So you can see here in the preset concrete canvas property data sheet, it covers everything from thickness and roll size, which we've just gone through. But if you look at the bottom of the screen there, there's also the savings in terms of embodied CO2 using GCCMs and comparing it with traditional concrete, which we'll go through shortly, and also the working time from hydration, which is 1 to 2 hours. So that's a key thing to keep in mind, particularly with our climate in Ireland, where it's usually raining when you're installing this material on site. There is that working time of 1 to 2 hours before the material begins to set. So typically there is no delays due to rainfall. And then with the post-set concrete canvas properties, that deals with everything from the compressive strength of the material, again, which is 60 MPa for the Type 2, 45 MPa for Type 1, and 65 MPa for Type 3. But it also covers the likes of the flexural strength of material using a 3-point bending test and the dynamic puncture resistance of the material. So keep in mind, all of that's on our data sheet. And this leads us into the British Board of Agreement durability certificate I mentioned at the start. So the durability lifespan of this type of material is 120 years for exposed erosion control applications. That's downloadable online, but some of the factors that they assess is the durability, climatic performance, and structural performance of the material for a range of erosion control and weed suppression applications. So before I finish off on some of the technical literature of the GCCM and move into some case studies in the region, I thought I'd just give a quick snapshot of some of the reasons that GCCMs can be designed and specified on projects. As I mentioned at the start, it's quick to install. It's up to 10 times quicker than conventional concrete, but also keep in mind it's quicker to commission. So because it gains 60% strength within 24 hours, typically you can put that asset back into service within 24 hours. There's also lower project costs, both in terms of material standpoint, but also from the speed of installation and the savings associated with that. and it can be installed under adverse weather conditions. The durability, as I mentioned, is in excess of 120 years, and the abrasion resistance of the material in hydraulic applications is similar to 70 MPa concrete. Also keep in mind that the reduced carbon footprint of the material. So for a lot of applications such as channel lining, interceptor channel lining, or ditch lining, concrete canvas GCCMs will replace up to 150 millimeter of poured or precast concrete. So right away, if you're using the 7 millimeter thickness of GCCM, you have 90% material savings. That associates with a 63% reduction in the embodied carbon or global warming potential using this material. And we'll have a couple of slides coming up on that. So there was an independent report recently released from Ricardo Energy and Environment, which we'll go through shortly. But just keep in mind that a GCCM product has a very low alkaline reserve, and it also has a very low washout rate. So typically it doesn't affect the pH levels in the water once you've installed and hydrated the material. For that reason, it's been approved by the EPA, the Environment Agency, and in this slide here, the Natural Resource Wales in the UK, where they directly installed the material for this salmon hatchery plant for ditch lining. And you'll notice on this slide that there's algae and moss buildup on that hydrophilic top surface. So while it's still preventing any root-growing vegetation coming through the material, it will have a buildup and mossing effect, so it will blend in better over the long term. And again, in terms of the life cycle assessment of the material, Ricardo Energy in their report ran this LCA, and basically, for people who aren't familiar, it does a cradle to grave assessment. It includes everything from sourcing your raw materials to manufacture, transportation, installation, and end of life. And when they ran the report, they found that the global warming potential of a GCCM product type 2 is 63% lower than a 150 millimeter of poured concrete. And you can see on the table on the right-hand side all the different points they've taken into consideration. So this is a really useful tool for a lot of the designers looking to work with GCCMs. Part of the report was also an interactive carbon tool. So you'll see on this slide on the top left-hand side, the carbon tool allows designers or clients to input all the data for a particular scheme or for a particular project, and it can compare a GCCM product with an incumbent poured concrete or hard armor lining solution, and it can actually factor in what the exact carbon savings is on a particular scheme. A key thing to this is obviously location of the project. So you can see on this particular scheme from Birmingham and Spaghetti Junction, which was a network rail and national highway scheme headed up by the Environment Agency, they replaced the incumbent solution, which was 150 millimeters of poured concrete, with a type 2 GCCM specification. And on this particular scheme, there's a 66% reduction in the global warming potential. So that's just an example of where the tool can be used. And we all encourage that it is used on schemes in the UK and Ireland. In terms of the application areas for GCCMs, I mentioned earlier, we have our watercourse specification guides, slope protection specification guides, weed suppression and containment specification guides. And this is a really useful tool for designers when they're trying to incorporate all the important data into one of their designs. To simplify this, the next slide shows 4 key installation principles for a GCCM product. And this is something that should always be taken into consideration when designing a project with a GCCM. And this should also be taken into consideration by the contractor who's installing the material in the field as well. So the first key installation principle is to avoid voids. So this typically means laying the material onto a geotechnically stable substrate. As you can see in the photograph here, that typically means that it's relatively smooth and uniform. It's free of any sharp rock or protrusions. They should be removed prior to laying the GCCM product. On some projects, we'll also recommend a geotextile, depending on the project. So keep in mind that's a key consideration before you lay the material. The second installation principle is securing the material together. Typically, what we recommend is overlapping the layers by 100 millimeters, shingled the overlapping layers in the direction of water flow, as you can see in the cross section on the left-hand side, and to mechanically fix the joints together at 200 millimeter centers with 30 millimeter stainless steel screws. So this gives you a high mechanical strength joint, but at the same time, it allows for if there's a high water table, to allow any water from underneath to drain out through your joints and prevent any hydrostatic uplift pressure. So that is a really good joint detail. The screw should be 30 to 50 millimeters from the edge. And you can see on the right-hand side here, typically an auto-fed screw gun is used in the field to apply the screws quite quickly. If a high water table isn't an issue on site, and if you want to improve the impermeability of the joint, you can add a sealant underneath the overlap. And typically the sealant is applied, as you can see in the photograph here, 30 to 50 millimeters from the edge. After it's been hydrated, the underlap, you flip over the top layer and then you screw through that sealant, which bonds around your screw. That will still give you a high mechanical strength joint, but also improve the impermeability of the joint in the field. And again, just in terms of edge fixings, which is also a key consideration, to join the material to the substrate, it's typically recommended to use 250 millimeter galvanized pegs. You'll see in the top right-hand photograph. This is pegged through each overlap within an anchor trench, and then you can backfill that anchor trench after it's been hydrated. And again, you can see on the left-hand side here some of the design features where that anchor trench should be a minimum of 150 millimeters in depth, and it should always be backfilled with non-erodible material. And that may depend on if there's a flow of water over the anchor trench, for example, it may be a poured concrete backfill, or it could be simply Site 1 material, depending on the flow. There also might be a requirement for intermediate fixings, depending if there's high hydraulic shear loads within a channel. This is a project that I worked on 8 or 9 years ago now in Canada, at Myra Falls, where they used earth percussion anchors at 1 meter intervals because of the high shear loads within the channel. This project was designed to handle flow velocities in excess of 20 meters per second. So intermediate fixings are typically only required when you have high shear loads within the channel itself. Third installation principle is preventing water or wind ingress around the perimeter of a GCCM installation. You can see on the right-hand side a project from the Avoca mines in Wicklow, where they dug on that particular project a 250 millimeter anchor trench prior to being backfilled with non-erodible material. This is a key consideration for any design because you don't want any water or wind getting underneath an installation. And again, the leading and trailing edges are typically installed into an anchor trench and backfilled with poured concrete to prevent any ingress. And final installation principle is probably the most obvious installation principle, is to actively hydrate the material at the end of each day. So a GCCM cannot be overhydrated. You can use an excess of water. We control the water cement ratio within the material itself. However, you typically require half the weight of the material in terms of the volume of water. So in this photograph here from a road scheme in the UK, they were using a type 2 GCCM, which weighs 12 kilograms per square meter. You'll need approximately 6 liters of water per square meter. And if conditions or temperatures are above 25 degrees Celsius, you may need more water, or you may need to rehydrate an hour later. However, in Ireland, we typically don't have those conditions in the field. But a key thing is just to remember to actively hydrate it at the end of each day. And in terms of the contractor perspective, they should always allow a couple of hours at the end of each day to make sure they actively hydrate it. So that leads us to the end of some of the technical details of a GCCM product. But I thought I'd just spend the last half of the presentation going through some case studies locally here from the south and southwest of Ireland. I mentioned at the start that watercourses and channel lining is a core application for GCCM. So most of the focus is on this type of application. I thought I'd start with the most local project in Cork, and that is the recently opened Macroom bypass. So I know everyone's very familiar with this scheme. It's a €250 million scheme, the Macroom to Ballyverna works. Concrete canvas GCCM was specified by Barry Transportation on this scheme for one of the water courses that was being diverted during the works. And it was installed by John Civil and John Craddock joint venture on this particular scheme. So you'll notice here that they specified a type 2 GCCM for this particular scheme on quite a steep one-to-one side slope in the watercourse channel. It had a 1 meter base, and again, you can see here the steepness of the side slopes. There was also significant curvature within the channel itself. And for that reason, we recommended a transverse layup in this particular scheme. So you overlap the layers by 100 millimeters in the direction of flow. And again, a transverse layup allows you to accommodate any curvature or pipe protrusions or inlet drainage pipes. And you'll see some of the photographs coming up on that. They used the bulk rolls, as you can see in this photograph, with a spreader beam, which was deployed from a 13-ton excavator. There was a few steps within the watercourse itself to dissipate some of the water energy as it moved downstream. And again, this gives you a good idea looking at the channel downstream of how steep that side slope is and the 1 meter base within the invert. So all the material was laid out prior to fixing it to the substrate with the 250 millimeter galvanized pegs within the anchor trench. After they installed the pegs and screwed the overlaps, all of the material was hydrated prior to any backfill. And you'll notice here there's a stilling basin, which essentially was a deep section of the diversion channel, which was used to dissipate some of the hydraulic jump within the actual channel itself. So the water is running through the culvert underneath the newly constructed dual carriageway into the stilling basin, then it flows downstream for 150 linear meters. So just over 1,100 square meters of type 2 GCCM was installed. And you notice here, as I mentioned earlier, that non-erodible fill was Site 1 material on the left-hand side, but on the right-hand side, they used poured concrete because there was a risk of water getting underneath on that side. So just keep in mind, depending on the erosion requirements, we may recommend poured concrete or just Site 1 material for the anchor trenching. And that's the final photograph from the N22 scheme. And you notice there a 700 millimeter HDPE drainage pipe coming into the section of channel as well with quite a bit of flow. And again, that transverse layout worked really well in terms of accommodating the curvature, as you can see in the background of the channel as well. So that road scheme is obviously open now and operating, and you can see it if you're ever driving on that section of road. And similar to the N22 scheme, we recently worked on the Killaloe bypass, which was work specified by RPS Group in Cork, and the main contractor was John Sisk and Son. So this was a really interesting project. We were in touch with the designer last summer. As people could remember, last June was one of the driest months on record, followed by one of the wettest months on record in July. Typical Irish weather, but to an extreme this time. And you can see from that very dry weather to very wet weather, the amount of scour and erosion within the invert of that interceptor channel. And the risk here is the stability of the slope on the right-hand side because of that water ingress. If there's any issues there in terms of slippage, then you're going to have construction delays on site. So it was decided that it required a hard armor lining solution, and they required material quickly on site. So a GCCM worked well. On one truckload, they were able to deliver 2,700 square meters of material on just one articulated truck to site. And similar to the Macroom bypass scheme, John Sisk and Son used a transverse layout, again, due to the steep gradient within the channel and the curvature. And again, using a spreader beam for deployment into their anchor trenches. They hydrated the material and applied the stainless steel screws at 200 millimeter centers along each overlap, as you can see here. And then they hydrated the material after it was all screwed and pegged into place. So very similar layout, and was able to accommodate the head wall, as you can see on the upstream section of works, the GCCM material, and then they backfilled with material. And you can see during the construction and installation of the concrete canvas and the channel, the amount of water and saturation on the right-hand side of the channel there. So even during those works, they were still getting a lot of rainfall on site. Thankfully, that didn't result in any delays with the material. I think this probably gives you a better appreciation of the curvature and the steep gradients on some sections of the interceptor channel. You'll always notice a drainage pipe on the left-hand side in the foreground, and that was carrying a small stream from a wooded area into that interceptor crest drainage channel. So it's quite a bit of flow, not only from the rainfall, but also from that stream as well, entering the location of the channel. So again, just shy of 2,000 square meters installed in certain sections, over 3,000 square meters in total along the steep gradients. And that's been in place now for just over 5 months. And similar to the two applications I've just shown everyone, GCCMs have been installed up to 8 years now in Ireland. And this is one of the oldest schemes that's been installed on at the Evoca mines in Wicklow. This was designed by CDM Smith in Dublin, with work carried out by Priority Construction on site. And you can see here, again, a transverse layout with a 250 millimeter anchor trench. This was essentially carrying all the clean surface water upstream at the Evoca mines and carrying it into the Evoca River. So the whole idea here was, because of the poor water quality in the Evoca River due to contamination from former mining, the idea was to carry that clean water without coming into contact with any contaminated soil. So you'll notice for that reason, It was a bit difficult maybe in the background. They applied a sealant underneath the overlap. And the reason for this was to improve the impermeability of the joint. So it's not in contact, the water's not in contact with any contaminated soil. So I was on site during the works on this particular scheme, and this was a photograph after it was finished. Again, quite a bit of curvature on this particular channel. And then a couple of years later, this was the finished scheme. So again, the GCCM product is there designed to carry that clean water downstream into the Avoca River. And then just looking downstream towards Avoca itself, you can see the GCCM line channel. So again, for watercourse channels, it tends to be the type 2 material. On that particular scheme, it was actually the type 3, 11 millimeters thickness that was used, simply because there was more abrasion expected within the actual channel itself. We're not confined GCCMs just to typical soil channels. It can be used for existing assets, as I mentioned. So we've worked with the likes of Irish Water or other utility providers where they have existing assets, whether it's concrete flumes on hydroelectric schemes, as you can see here from a scheme in Scotland with Scottish Power. You can see that actual concrete flume is in quite good condition considering its age. It's over 50 years old. However, you can see there's weeds starting to grow out through it. There was significant water loss as well, which isn't ideal for the client. They were losing too much water. They decided to specify a type 2 GCCM product on this. So the 7 millimeters thickness. And as I mentioned earlier, because of that thin material, they were able to preserve the volume capacity within that flume for the hydroelectric scheme, which is really important for the client. It was also able to be put into operation within 24 hours. But just keep in mind, if it is a concrete substrate, you cannot use stainless steel screws. You'll have to use stainless steel concrete screw anchors to screw through the overlaps into the actual concrete subbase to get a very secure connection within the asset itself. So there's a few differences depending on what subgrade you're looking to use it for. And you might be able to make out on this slide the fixing detail. So it's 500 millimeter centers with a concrete screw anchor with a 15 millimeter washer on this particular scheme. There's also a number of inlet channels it needed to accommodate on the right-hand side, just to bring some water in from that slope. And they installed some erosion control matting on both sides of the channel, just to ensure quick germination on both sides of the channel. This was a photograph from 10 years later. So as I mentioned earlier on in the presentation, the GCCM material will blend in a little bit better with the surrounding landscape over time. And that's primarily due to the hydrophilic top surface, which has a buildup of algae and moss over time. So you can see that finished project after 10 years. And just moving into the final application, which is for culvert repair. I thought this was an interesting application to show for GCCMs, again, for existing assets, where a culvert, whether it's a masonry culvert or a steel arm pull culvert, that's structurally sound, was having issues with invert water loss. So you can see here in the invert, the bitumen has actually started to wear away. Due to this, a lot of the water was starting to get through the culvert invert and start to undermine the whole structure. So Transport Scotland on this particular scheme wants to prolong the design life of this structure. So they decided to use a GCCM to line the invert and the side slopes. And you'll notice here that SEPA, they recommended a large enough pipe to allow fish to go through. So that diverted all the water, so over pumped. And this allows a dry working area for the contractor installing the GCCM. And again, you can see that's kind of jacked up in place with wooden planks. The crenellations within the actual culvert itself was also filled in with a semi-dry grout mix, just to ensure your smooth and uniform profile. Always difficult to get good photographs within a culvert, but you can see the contractor done a great job, Bear Scotland, installing the GCCM in that transverse layout across the width of the culvert. And again, fixings will change depending on the subgrade, as I mentioned earlier. On this particular scheme, it was stainless steel tech screws with 15 millimeter washers. And you'll notice in the final photograph here that they've actually grouted up the top edges of the GCCM. So if there's more flow of water than anticipated, it still prevents any water ingress at those critical points. So that brings us to the end of the presentation. Thanks everybody for your time. I just wanted a quick summary slide. And again, if there's any questions online for Patrick, feel free to put it in the Q&A function. As I mentioned at the start, all GCCM products are designed for your non-structural erosion control or weed suppression applications. The design life of the material is 120 years, so it's designed for your long-term projects. And there is some environmental advantages there over your other traditional hard arm solutions. I'll finish off with a final photograph of the different applications of GCCMs. And on that note, I'll finish the presentation. Thanks everyone for your time today. Thanks again, Patrick, for setting up the presentation. Thank you.
Thanks, Shireen. I'd just again like to reiterate there to open the floor here up to questions and online, which can be typed into the Q&A function. I'd start with a question from myself there. I was just wondering about the transport of the material in regards to contact with water and moisture. Like, is there a degree of, can it get small with wet and kind of come into contact with some moisture, or is it a very, is there a,
yeah,
you know, the way sites are, they're not exactly, you know, they can be hard to keep stuff dry.
Absolutely. It's good to put up a nice dry photo of it on the slide here, but yeah, when it gets to site, it's a different story. So as I said, most of the concrete canvas rolls, or all the concrete canvas rolls delivered to site, will be palletized, and they'll be in 3 different layers of shrink wrapped plastic packaging, which is a good start. We have seen issues sometimes in unloading where they might pierce some of the packaging if they're a bit clumsy on site. So for those reasons, if it's being stored outside, Patrick, we also recommend put some additional tarpaulins over the material. The last thing we want is any water ingress. The good news is, as a final layer of protection, the actual PVC membrane of a GCCM is always rolled upwards. So even if water gets in, it will actually hit the PVC membrane and roll off. But just for QC purposes, we always recommend put some additional tarpaulins over the material just to keep it dry. The last thing we want is a contractor to open it, leave it overnight and let rain get in. So yeah, absolutely, to keep it protected, maybe some additional tarps. Yeah.
Any questions from the floor? I have one online here. Can water velocity be controlled by the use of baffles made of rock or other materials constructed on the GCCM?
Great question. So really good question there. So the Manning's coefficient of a GCCM is 0.011, similar to poured concrete. So it does speed up the flow of water. So like that question, really important for designers to take into account whether baffling is required to slow down and dissipate some of the water energy. If it is required, we have some really good baffling details for GCCMs. You can absolutely use rock armor on top as some of the baffling details. I mentioned the Evoca mines in Wicklow, which is actually in a public area. You can go and view that particular project. They actually incorporated precast steps within their channel as well. And the concrete canvas was then lined over those precast steps, fastened into them, and that helped to dissipate some of the water energy as they moved down. So that baffling detail can be used absolutely on any channel application. Yep. Thanks for the question.
Another question here. Excellent presentation, Ryan. Thank you. You've shown at one of the sites and one of the slides the deep, steep embankment earthbound covered in mats. Can you say what is the maximum recommended depth to height and the maximum slope of the embankment this material can be used at? Thank you.
Yep, great question. Thanks very much. So for slope protection applications, there is a really good specification document that covers all the different parameters. As I mentioned, GCCMs are used for your slope protection rather than slope stabilization. There's no real restrictions in terms of the vertical plane installed in the material. As I mentioned at the start, that 3-dimensional fiber matrix, it prevents dislocation of the cement fines. So even if you hang the GCCM on a vertical plane, the cement fines are still in place. In saying that, if you're installing the material on a particular slope, you may require intermediate fixings. For example, if that slope length is greater than 5 meters, we may recommend an intermediate fixing. That can take the shape as an earth percussion anchor or a soil anchor, and all of that's covered in the specification guidelines. But yes, if it's greater than 5 meters in length, we typically recommend an intermediate fixing on the slope.
Another question from online there. Can GCCM be utilized in the marine environment? Saltwater exposure / substrate conditions, wave action issues, etc.
Great question again, a common question we get. So In a marine environment, concrete canvas GCCMs can certainly be used. So in terms of even hydrating the material, it will set underwater, for example, and you can actually use salt water to hydrate the material. So there's no limitations in that regard. We've been used in certain slope protection applications within a tidal zone, but because there's dynamic loading from the wave action, we have to take it on an individual project basis for that type of application. So sometimes, for example, concrete canvas GCCMs can be used to reline a slope, but rock armor will be put on the face of that installation, protected from the wave action. So it just depends on each project. So if someone does have a particular project, feel free to get in touch and we give advice on that.
There was one earlier question that I answered. It was just that your presentation will be available after we will email that out to people after the event.
Yeah.
Another question here is one that I was going to ask myself. Is excellent presentation, Ryan. What is the approximate price per meter squared of the product?
It's usually the first question.
Yeah, I'm surprised we got as far as 5 questions on that.
Yeah. So the price of the material depends obviously on which type of strength class, whether it's a type 1, type 2, or type 3. But in terms of a euro square meter rate, it starts from 22 euro per square meter and upwards, again, depending on the volume of material and whether it's a type 1, type 2, or type 3. And that's for material cost supplied. Yeah.
Are there limitations, temperature limitations for laying hydrating GCCM?
Yeah, great question, given the weather we have today. So in Ireland, we usually focus on the freezing temperatures more so than high temperatures, obviously. So in terms of high temperatures, first of all, if the temperatures are going to exceed 25 degrees Celsius, you may need to hydrate the material twice. Also, if you're installing this on a steep slope, you may also need to rehydrate an hour later after the initial hydration. The weather we have at the moment, there is certain things. So if you're installing material during the day and it's above freezing, that's absolutely fine. If it's going to dip below freezing, perhaps -1, -2, there's certain things you can do. You can cover the installed material with plastic sheeting after each day and use a warm water to hydrate, or you can also add an accelerant into the water to allow the material to set quicker. But again, if it's going to fall colder than that, if the temperature is going to be lower than that overnight, then we wouldn't recommend installing the material. But again, if it's just below freezing, you can use your plastic sheeting, warm water, or an accelerant. Yeah.
So that's all the questions online for the moment. Any from the floor?
Just right,
Yeah.
that was saying, what's the level of support you provide, design support, to anybody who's using this product?
Yeah, great question, Jim. So from our perspective, we have technical representatives throughout the UK and Ireland. So anywhere, I realize engineers who are based in corporate designing a project in the UK will have technical representatives in all different regions. We can provide support, non-indemnified design advice. There's a number of services we provide, such as CAD drawings, specification documents. It can be really useful for designers to incorporate it into their own projects. So yeah, we always encourage people, if you're considering the use of GCCM, feel free to get in touch and we can go through some of the recommendations on the type of material that should be used as well. Yeah, thanks, Jim.
Just one more online there.
Yeah.
What's the design life and warranty of the product?
Yes, so great question. So we have that British Board of Agreement certificate that's downloadable on the website as well. And it's a durability lifespan in excess of 120 years. And a key component of that is obviously using the right type of material for whatever erosion control application you're looking to use it for. And what we say as a material manufacturer is all GCCM products that are supplied to a client will always meet the minimum performance requirements set out in the ASTM standards. So essentially all GCCM products supplied from concrete canvas will meet the data sheet and those minimum performance requirements when it's delivered to site.
Any more questions? So look, I think that's all the questions online and in the room. Just on behalf of everyone, I'd like to thank Brian for a very interesting and knowledgeable presentation. I was surprised to see the wide range of uses from channel lining to weed suppression and indeed the range of delivery options. The durability of 120 years, faster time to service and reduced carbon footprint. They are highlights for both engineers and the clients. I think that they'll both see the benefits of the use of it. The detail in the presentation has me quite confident that I could actually install it myself tomorrow. So I'd like to thank you for that. And finally, seeing the products that said the GCCMs in projects has provided a good visual of it for everyone here. And I think we were lucky in the Cork region to actually visit the N22 as a
Very good.
visit last year. So we saw them. We saw your product in place, and
That's great.
it does look good in fairness, and it's good. Or not, my knowledge I didn't know much about it, so again,
Yes.
I was questioning the product when I saw it on the day.
That's great.
So, look, again, on behalf of all the attendees, I would again like to thank you for very much a great presentation.
That's great. Thanks very much, Patrick. Thanks everyone for your time today.
Thank you.